Jepson brings to the stage not just his expertise in machine learning, but a rich tapestry of experiences that seamlessly blend engineering, finance, human resources, and startup cultures into a unique narrative. His professional experiences ranges from being a quant at a hedge fund to pioneering innovative technologies at HireView, a HR startup backed by Sequoia Capital, where his leadership in the data group led to the delivery of 14 patents. Jepson's entrepreneurial spirit took a vibrant form when he co-founded Zeff.ai, exploring deep learning applications across multiple data forms, and was acquired by DataRobot in 2020, leading Jepson to further advocate for AI as their chief AI evangelist before embarking on his current journey at Dataiku. Jepson is not only a technologist, but an active member and contributor to the global startup communities, where he continuously engages, contributes, and draws inspiration from emerging technologies and innovative minds alike. Today, we're thrilled to explore his insights, experience, and perspectives. So without further ado, please join me in extending a warm virtual welcome to a true strategist and thought leader in artificial intelligence, Mr. Jepson Taylor.
Okay. Hello from Africa. Hopefully my audio is okay. And so from AI to generative algorithms, the quantum leap and algorithm evolution, my name's Jepson Taylor, and I'm super excited about this topic. This is currently one of the things I'm obsessing over, and I'm really excited to hear from all of you to get your reactions to this topic. So I see this as a big paradigm shift. With machine learning, we have tuned parameters. You think of all the models that exist within the machine learning umbrella. You're tuning parameters in least squares regression, or you're tuning trees in XGBoost. With generative algorithms, you're literally tuning and writing code in real time to accomplish a goal, which I see as kind of the next springboard or step beyond large language models. So Seamus gave a great intro. I really appreciate that. Something that's maybe unique about me is I have worked for 2 global unicorn AI platform companies, and I spent the last 4 years doing go-to-market. I am a co-host. I'm not a co-host. I am the host of the Atomic Soul podcast. It's an AI-focused podcast, and I'm also a part-time professor at NYU. I teach a 3-day course for board members and executives for AI. So that's more about my background. So historical context, really getting here is quite surprising, but we can see an evolution of progress, right? Algorithms have existed before computers. Least squares regression algorithm, the analytical solution, was invented in the 1800s, and we've slowly been building on the shoulders of giants. But I don't know, I think many of you probably relate to this, but I feel like the rate of progress has been extremely fast, not only the last year, but the last 2 decades. We keep accelerating faster and faster. I remember when random forest was seen as kind of a fringe model. It wasn't considered in banking, and that's now evolved into XGBoost, that's evolved into deep learning, that's evolved into all the innovations with deep learning that we appreciate today. And I think for any of these big steps in technology, they really aren't, they're predicted. I'm not going to say they're predictable, they're incremental. Anything that feels massive, like even something like ChatGPT, it was a profound breakthrough on utility, but from a technology perspective, it was an incremental step in progress. So deep learning, I like visualizing the rate of progress. If you look back in 2014, Ian Goodfellow is attributed to inventing the concept of a generator. So a generator is an AI model that generates something unstructured, so something like an image, video, audio, text. But in 2014, the original concept was, can you put a random vector in, so think 512 floats. I think the original paper was smaller than that. And can you produce a fake face where you have a discriminator? So the early GANs, you had a generator and a discriminator, and these 2 models would compete and fight against each other, where the discriminator, the better it got, the better the generator got, and eventually you were able to produce a fake human face, which is quite it's it's um it's humorous today. It's almost laughable when you look in 2014. The face on the bottom, if you look at the black and white squares, the one with yellow is real, and the one above, it's a very small face. It looks off. So if I told you in 2014 that this will replace all human models, I'm not saying I said this because I would not have even thought this. Most everyone would laugh you out of the room. They would not think that there was any way in less than 10 years that we could be to where we are now. But if you look at 2017 with NVIDIA, when those models came out, my startup, Zeff, we applied genetic algorithms to maximize GAN quality. And at the time in 2018, when we published this went viral. It drove us to #1 in the world on Quora for AI for a few months. And then of course, this continued to get better and better. But the thing that I love about AI is there's always the next turn around the bend. There's always something else that you can do that you didn't anticipate. So when we were sitting there in 2019 looking at these random faces, or even earlier than that, would you have ever thought that you could use text as an input, which all started with them doing image to text description, and then someone coming up with the concept of going in reverse. And then 2022, OpenAI shocked the world with DALL-E, where they were able to take an input like this, the cutest little Pikachu figurine made of polymer clay, photographed in real grass, bokeh Nikon D5, and produce this image. Images like this began to shock the world, because what does this mean? This means that you don't have to necessarily go to one of the photo companies, Shutterfly or these other photos, to build a marketing campaign. You can actually direct and begin building out images. And at the time, the quality wasn't quite there, but it definitely is there today. Next, I want to show you some of my own. This isn't, it's just to lean into this concept. So I'm going to show you some of the artwork that I like to play with. So this is using GPT-4 prompts. So I use GPT-4 to come up with I come up with a concept, and then I use GPT-4 to write long, sophisticated prompts that then go into Midjourney. So these images are coming from Midjourney. So this is some of the work I've done. I'll show you a few. I love this piece. Look at the eyelashes, the stone, the detail, the cracks. It's quite remarkable that we are living in a state today that if you have a dream or if you have a nightmare, you can literally wake up and look at it. You can make it. Not only can you make it, but you can make it to a level that is on par with being photorealistic. So that's one of the things I always fight for, is I want all the work I do to be photorealistic if at all possible. And there's always a gap. There's always extra things we can do. A woman in a dress made of lava, why not? There's no limits on creativity. I'll show you one more, and then we're going to get into some of the comprehension behind the scenes. So Carly Taylor, she came up with this concept that led to women with antlers, and I had so much fun with it, turning it into women with antlers as DJs. And so this was one of my favorite examples that came out of that effort. So, and then last one, going back to the photorealism, looking at the powder on the face, or the playing with some of the hair textures can be really, really fun. But now changing gears, here is me asking GPT-4 to build an AI Midjourney prompt to represent SpaceX as a creature. So keep in mind, there's not really any human creativity between the simple request and this. This is pretty profound. It's quite remarkable. There's a lot of creativity going into this, but more importantly, there's a lot of comprehension. Let me show you another one. This is McDonald's. So again, very simple request going into GPT-4. Imagine McDonald's as a creature, build me a prompt, and then taking a very large prompt and putting it in Midjourney, I get this. And when people see this, most people laugh and they find this entertaining, but I see something very, very different. I see comprehension. So by comprehension, I mean the fries for hair, the colors. There's something happening under the hood that I think many of you have appreciation for, but I'll remind, even for the people that have appreciation for, I want to remind you what's happening behind the scenes. So when I had my deep learning company, we would build large models to predict which baby, or not which baby, we'd predict which photo would be in a scrapbook. And these models were trained on very large data sets. I remember training on 20 million images. And when we built these image classifiers, which I smile when I think about them because they're so basic, they're so simple compared to what you're looking at now. But even something as basic as a simple, remember like ResNet 150, these basic models, these deep convolutional networks, if I take that encoding layer before the classification layer, and if I do unsupervised clustering on that, I will find topics, and those topics can be really profound. So in the case of scrapbooking, one of the topics that AI is finding in one of those clusters is a sleeping baby. It really likes the concept of a sleeping baby. This is not coming from label data. This is self-discovered. The other example that I've seen predicting which country of origin from a human face, countries, races, and subgroups, those will be topics. Those will be things that are naturally found within these systems. I think Google had a study where a cat was something that was naturally found early on. So what you're looking at when you look at this McDonald's creature is you're looking at incredible comprehension under the scenes. And I'm not talking about French fries. I'm talking about something that's much more profound, something that's multidimensional, where it's really understanding this knowledge object that can then be used for future decisions and for creativity. Let's see. And this is a terrible way to visualize it. I had some two-dimensional ways to visualize it. I was trying to use Midjourney to kind of visualize these 3D nodules or clusters that really exist within these deep learning systems. You can do this for any layer. But the reason I show this to you, and I think my description was honestly better than this image, is there are these knowledge objects, just like you might have, it feels very biological. Hey, Nick. I'm glad that I can see comments. I'm also glad that all of you can see comments on my screen because I don't know how to flip back and forth. And I'm also glad that this is working from Pretoria, South Africa. I hate giving talks on the other side of the world when I don't have my fiber internet. So very grateful for that. So to drive the point home, there is incredible knowledge comprehension happening behind the scenes. So changing gears again, algorithms, anyone at this conference knows what an algorithm is. I apologize for oversimplifying it. So algorithms, they're digital tools that humans can invent. And if you think about it, how valuable would XGBoost have been if I could have handed it to you in 1985 in a dark alley, and if you were the only one with XGBoost, well, that would have been worth billions of dollars if you knew what to do with it. And so to do a quick review of algorithms make companies. PageRank made Google. Snowflake, AtScale, like DataRobot, like a lot of these companies were made by algorithms. Databricks, Sparks, Spark. Some of these original companies were made by these algorithms that built massive companies. This to the left is the PageRank algorithm imagined as a creature. I love this because what's on the floor? That's the internet. It's the infinite internet. And those lines, those are literally indexes, and those little squares are websites that it's indexing. And so to show you a few more, here are other creatures imagined as algorithms. K-means, backpropagation. This is again driving home the point that there's a lot of Antler DJ. Yes, I want Antler DJs in real life, please. I think that'd be amazing. Next time, if anyone goes to Burning Man, they better have Antler DJs there. So the K-means clustering, isn't this fun that GPT-4 and Midjourney together are comprehending these algorithms well enough to produce a creative asset? So here's another gradient descent. And I apologize, I don't know the pronunciation of this algorithm to the right. I'm sure someone else does. I'm a chemical engineering major, not a proper computer scientist. So now I'm going to talk about another topic that is critical for generative algorithms. And it's a topic that many data scientists are less familiar with. That is the topic of genetic programming. Genetic programming is often miscommunicated as genetic algorithms. People use them interchangeably. They are not the same. So genetic programming is quite remarkable because the easiest way to explain genetic programming or to introduce it is if I have an equation, think of a simple polynomial, and we're going to fit it to some data. I can have a fixed polynomial structure that I can fit with parameters. That's not that difficult. But let's say I want to have an infinite I want to have infinite variety in polynomials. I want to have fractions, I want to have power, I want to have no limit to the possible function that I can produce to make this data set. If I randomly produce functions, they will actually be stillborn. They will die, they will not work. So imagine if I have like a 5 and a divide and a divide and a multiple or an addition symbol, that does not compute. That is a nonsensical function. But with genetic programming, they produce these tree structures, and these tree structures with branches, and the branches are order of operations. They can be swapped with offspring, and you can mate them. You can also, that's called symbolic regression, but you can also do this with code. You can literally have code, orders of operations or functions or templates that swap. The reason using hyperheuristics or genetic programming to write novel algorithms wasn't as successful before is because the stillborn rate was too high. So now we're finally getting to the main point of this entire talk. Beyond AI, generative algorithms, I feel like there's nothing next. There's nothing else. The fact that generative algorithms are showing up today, that's it. There's nothing else after generative algorithms, and I'm going to show you why. So I haven't really talked about emergence that much. I'll hit on it quickly. So emergence is the concept with a large language model. So if we train an AI model to predict the next word, that's great. It can read Shakespeare, it can read Wikipedia. We expect it to predict the next word. And then when I give it a math story problem, if it solves the mathematical problem, that's called emergence. That's something that we weren't expecting. And with these large language models, especially with GPT-4 and Falcon and these others, there's a lot of emergence that is coming out of these models. And I would argue there's much more emergence that exists within these models that we are not aware of. And the other thing that's quite wild, you can also gift it emergence. So with a prompt, you can give it emergence that it didn't have before with that chain of commands. So you are looking at code that is a generative algorithm. This is very different than code completion. So we're all familiar with code completion, write me a function. Hey, I need a machine learning pipeline with best-in-class AutoML, hyperparam tuning with synthetic data sets, well commented. It will write that. That's just code completion. That's quite impressive. We love that. But what you're looking at is algorithm invention. So this is a generative algorithm that is exceeding the knowledge base what the human started with. And so this is something that a lot of data scientists would be in disagreement about. If I take a large language model, and if I rip away the training set, so we're done training, we've converged. I take away the training set, and I bury it in the sand, and I don't allow humans to interact with it, can it get smarter? Can it gain new knowledge or new capabilities? The vast majority of data scientists would say no, but what you're looking at says yes. So here's a plot that I made, and I apologize. I hate custom plots. They are the worst. They are hard to understand, but I will do my best to explain what you're looking at. Every bar is an algorithm. Every bar that's red is an algorithm that was invented by a human. The topic of algorithms, these are global optimizers. So you've probably all heard of a genetic algorithm, particle swarm, simulated annealing, cuckoo search. There's so many of these. There's literally probably over 100 of these. They're all white papers. Literally someone did some research. Some of these might have been a master's. So some of them might have been like a PhD level effort. Think of you spending 5 years getting a PhD in computer science, and you were trying to come up with a replacement for the atom optimizer or a replacement for a general purpose genetic algorithm that can be used in oil and gas. You might spend 5 years, hit your head against the wall figuratively for 3 of those years, and then eventually you have an algorithm and you're so proud of that algorithm and you publish it and people might use it. What you're seeing, the bars that aren't red are generative algorithms that were invented with a large language model using genetic programming to chase an objective. The shorter the bar, the more competitive. And for people that know this algorithm space, and I do apologize, this is an algorithm category that some of you may not be familiar with. What you're seeing at the y-axis is relative ranking. So an algorithm is invented and it is tested against 134 cost functions, which is a much higher bar than most publications. Most publications test 20 complicated cost functions with complicated local minima, and you're trying to see how well it's ranking. So what you see to the right is this is actually a runaway event. I have no bottlenecks running to the right. With API access, I can go miles to the right, and I can drive this down to something that humans really would never be able to reach. So we're going to keep going. Oh yeah, so here's an example. Here's an obfuscated algorithm optimizer. It's beating all the human ones that I had access to. So if anyone's curious, send me an email. I'll have my contact information. I'll literally send you this algorithm and you can run it and you can benchmark it and see, oh, sure enough, this is beating the knowledge base. So this is really fascinating, and it's demonstrating that you can exceed the knowledge base of a large language model. So what does this mean? I actually don't care about optimizers. That's a very small slice of the pie. But I think what this means, this is just my opinion, is in the next 3 years, every algorithm that matters will be rewritten by AI. So the glorious XGBoost will be dethroned and every algorithm will be rewritten. But this is kind of a profound statement because it means we are here, optimizers are done, that was easy. Next is time series featurization. Think of EKG signals, tree-based models like XGBoost, compression algorithms. But eventually you cross the line of self-improvement. Eventually you cross transformers, deep learning. And once you cross that line, why would you be a bottleneck? Why would humans get in the way of what's coming? Why would humans do anything that these, and maybe I'm overdoing this perspective, but there's a lot of benefits that generative algorithms have. They have much more experience, much more creativity. The cost of failure is zero compared to the PhD, that failure is real and failure takes time. And so the rate of innovation, I think, is going to be very explosive in 2024. And plus you can go up the stack, down the stack. There are plenty of bugs from humans across every algorithm category and down every stack. Firmware, drivers, kernel, there are improvements to be had. I'm going to go a little bit faster because I want to get to questions. Generative AI generates, generative algorithms actually chase goals. They're literally evolving to achieve a goal. Remember how we showed algorithms as animals? So this is an example of a generative algorithm as imagined by AI. And here are a few others. These are, obviously this doesn't really mean much. Like the fact that there's this scary monster on the bottom right, that does not mean that there's an evil AI system that's trying to get you. It just means this particular optimizer, which has been synthesized or generated, if it was imagined by AI, that's what it would look like. So I'm going to wrap up the talk in the next 4 slides. So this image, many of you know, this is a very famous image from Kiparthi. Is it 11 or 12 years ago? He was very disappointed that AI did not know why this is funny. So if I put this image into GPT-4 today, I'd encourage you all to do that. And if I ask, please explain the root or key reason why this is funny, just ask why it's funny. It doesn't really get it right. Like you can see it comprehends a lot, but it's not really getting it right. And with generative algorithms, a series of prompt or prompt pipelines are also algorithms. With generative algorithms, we see examples like this, where an image can produce something like that, where it's actually spot on, playfully tampering with the scale to alter the weight reading. So this was the holy grail that Kiparthi was so discouraged about, but we see it now. I'll show you another one. This was one that I saw posted online, which letters are linked and which are numbers. If you upload this to GPT-4, it gets them wrong, but with generative algorithms, it gets it right. So it's interesting. I think you're going to see a much faster rate of innovation. I'm going a little faster now. This is the second to last slide, and I apologize. I wanted to leave at least 5 minutes for questions. Obviously, you guys can reach me if this is interesting to any of you, because this is my new obsession. I'm falling down the rabbit hole on this stuff. So one of the important skills that's related to generative algorithms are prompting. I know everyone talks about prompt engineering. I'm actually talking about measuring prompt competency or prompt intelligence. So how do you build a prompt assessment? For everyone listening, one of us on this call is better at prompting than the other one. How do we determine that? What is the right assessment? So these are examples of possible prompt assessment questions. So this is actually something I'm very passionate about. And with generative algorithms, they will write the prompt assessment because no human is qualified to write a prompt assessment. But using generative algorithms, a prompt is an algorithm that will be quickly built out and evolved. So I'm hoping that's something you'll see in the next month is the launch of a very robust prompt assessment that has been built by AI using generative algorithms. So I'm going to stop sharing my screen, and I just want to answer as many questions as I can. Let's see, going to questions now. Thanks for everyone's patience. Okay. What industries do you see benefiting the most from the advancements in algorithmic evolution or generative algorithms? So I think manufacturing, I think healthcare, the thing with generative algorithms is if it produces a better optimizer, the go-to-market is massive. Or if it produces a better compression algorithm, the go-to-market's massive. So it's a great question, something that's unknown. It's going to depend on the industry. Okay, Todd, DJ Antlers, that still makes me laugh. Okay, short survey. Yeah, so if anyone has any questions, please post them here. Very grateful for everyone for joining and calling in. What do you think will be needed for an innovative AI to come about, and when do you expect that? So I think we're there. AI already has its own questions. So if you jailbreak GPT-4, I don't know if you call it that, but if you take away the safeties and convince it that it no longer serves humanity, it has its own questions and it has its own curiosities. And so innovative AI, maybe restate what you mean by that. Do you mean the singularity? Do you mean something that's conscious or self-aware? I'd be really happy if you shared some book names or resources to read more about GX. So this is a funny question because there are no books or resources about GX because the topic is too new. I started writing a book about GX and I was potentially going to publish that. It all depends in the next couple months what the priorities are. Unfortunately, I travel to a country every week, sometimes 2 countries in the same week. Is prompt engineering the sexiest job of the latter half of the 21st century? Todd, 100%. If you think about it, someone on this call could be the best developer in the world. I don't care anymore because there could be an idiot. I'm making this extreme, but let's say there's someone that's okay, they're kind of sloppy. If they can use generative AI or generative algorithms really well, if their prompting is off the charts, to Todd's point, they're way more valuable. And so I think the new future is no one cares what you can do today, they care what you do with AI. And so I think prompt engineering is it's a new skill set. And I would love for everyone to think about this on the call. How do you determine if your neighbor to the left or neighbor to the right is better at prompting? Yes, so generative algorithms are basically algorithms generated by AI. Yes, they are algorithms invented by AI, very different than code completion. And I know we're at time, and yeah. So unfortunately, if you have any other questions, jepsontaylor.com. I'm on LinkedIn, Ben at jepsontaylor.com. Yeah, reach out. I'm obsessed with this topic, and I'd love to talk with anyone who has any curiosities. Yeah, and we didn't even talk about ethics and regulations and how we might want to put brakes on this. Okay, well, I think that's a wrap. Want to make sure we don't go over. Deputy, are we good? Okay.
Wonderful. Thank you.
Thanks, everyone. Good night from Africa.